answer given.
Oh.
So I don't know how to get it. I don't know. That's where I'm still lost. I've been researching that, trying to find how to get that, and I still
Okay,
I don't have a clue.
that was for number 17, right?
Yes.
What was your number? You told? Can you repeat it, please?
6.652. That's the correct answer.
6.6.
52.
You said 6.652.
Yes.
Okay, I recorded it.
Recorded it where?
Here in my laptop.
Okay. So
okay.
Looking at it, I still don't know how to get the margin of error. I don't know how to figure that. I mean, I look at the equation and it's like, okay, well, that makes sense, but it doesn't seem to ever work. I don't know.
Well, should we go to the quiz?
Yeah, let's do it.
Hey, before we go there, let me ask a question. When I copy things off the spreadsheets they allow us to use, and I highlight a column and I drag it down to get the whole column, I keep getting a circular something, a circular, I get caught in a circular and I have to copy one column and close out that spreadsheet and reopen it. Are you guys finding the same thing? No?
No, I haven't noticed that.
Okay. Yeah, I'm on Excel. It's just me then. No big deal. All right, let's quiz.
Hopefully this one won't be as bad as the last one.
Whew, that was a doozy.
Yes, it was. I think we're all suffering still from it.
– 18 questions. Holy cow. What do you guys use to draw the bins, the histograms?
I use the spreadsheet, which is the quantitative descriptive.
You do use that, okay. Okay.
That's how I get my histograms, my QQ plots, all of that.
Okay.
So question number 3. To be able to do these, that we have to have a simple random sample.
Yes.
And the distribution has to be approximately normal.
Yes.
The first two, right?
Yes.
A and B.
I believe so.
That's what I'm reading.
Sorry.
Number 4.
That's number 3.
What did we say 3 was?
The first two ones.
Okay.
A and B. For number 4 is the T-score.
I think so.
Yeah.
Yes, it's in the book. For number 5 is the letter B.
B.
Yeah.
B.
Otherwise, they'd be dependent samples.
Okay, dentist office bills.
I don't like those.
I don't like them either.
I think if we don't like him, we should be able to skip the question.
I don't think that flies though, Dan.
I don't like exams. Let's skip them.
Yeah, I agree with that one too.
100% for everybody.
Let's skip.
The mean bill
Okay.
at the IF office in Rexburg B2.
You have to open the Excel file.
Yes.
Yes.
Do you guys enable editing before you copy and paste? Does
Yes.
that make a difference?
Yeah,
You
I
do?
Yeah, I do.
Yes, I didn't have problems.
I've had a ton of problems with
Okay.
Yeah, you're supposed to
Yes,
enable editing
patience.
the newer versions of Excel.
That's where you're getting your. That's where you're getting
Yeah,
messed up.
that is probably why you're getting the error.
It's because I need to update it.
Or do you need to
You
enable
need
it?
to-
I have enabled it and I have not enabled it, but maybe I just need to update some more.
Just enable it before you do anything. Do that first, because that's if you don't, it's going to mess you up.
Okay. Then I'm just going to copy both of these columns over into that spreadsheet.
Mm-hmm.
Okay, from a hypothesis, mean Idaho less than the mean.
I got 37.996.
For the DF,
Yes.
yes.
Hold on, wait, say what?
37
Your degrees
point.
of freedom, no, your degrees
Yeah.
of freedom is one less than your sample. It's n-1.
But they said here that the,
You have to pick the number from the chart, from the Excel file, according to the example we have here in the book. We have
Right.
to do it. Where?
I know, but what is the degrees of freedom? That is
Yes, I know
one
that
less-
is n-1. Yeah, really,
Right,
I know,
so-
but in this case, in the book, it says that we have to. Okay, it has no sense. These instructions to run it to 3 if we know that is n-5, so there are no decimals there.
Right.
So, but according to the book,
There should never
we
be a
have to
decimal in degrees of freedom.
I believe-
no. In the book, there you can find the explanation. I'm looking for that explanation here in the book.
I think it said this week there's going to be. I think it said there are going to be decimals in it this week, and we just read it off instead of one less. Because when you have two samples, you can't do one less because there's different amounts in each column.
Yes. Sometimes they are the same amount of numbers, but in other cases, no.
I think that's what they said. I'm looking for it.
Miss that.
But here it says, state the degrees of freedom. The degrees of freedom are given as a decimal number. You will notice this is not a whole number. This is called the Satterthwaite approximation.
Oh, sorry.
Yes.
I was on the wrong test anyhow.
That's okay. Just record the values it's given to you in the software.
Yep.
Yes. It says the instructions are there.
Okay, I got it. I
Okay.
missed that.
So we are taking the 37.996.
Yes, I took it.
We want-
For the null hypothesis, you guys just leave it at 0.
Hold on.
Sorry.
So on this one, there is no null. It's a confidence level of 10 or 0.10 and less than.
So the null just stays at 0.
Well, okay,
Null
so
is their
on the
equal.
spreadsheet, you have to do the 2-sample t-test for means as opposed to the paired sample. That's where I was off on spreadsheet.
Oh, the 2 sample.
Yeah, I know. I forgot to move over to the right spreadsheet again.
So Rexburg is the variable 2.
To determine if the mean bill at the Idaho Falls is less than.
What is the standard deviation for?
Well, yeah, because the variable 1 would be the Idaho Falls. Variable 2 is the Rexburg. So
Well, you guys are
since
hustling. You're on
Are you guys still
What
on
number?
deviation.
I think we're on 7.
You just copied that off, the sample standard deviation for Rexburg. Isn't it right out there on the spreadsheet?
Yes, it is. It's 206.637.
What do you guys get for
It's
number
a spread.
6?
It's from the spreadsheet.
Number
What is it?
6.
Yeah.
If you put the variables into there, it'll give you degrees of freedom of 37.996.
Mhm.
Okay.
Yes. And the test statistic,
That would be our
Is the T,
score,
the T score, minus
negative 0.4.
0.434.
Sorry, what was that?
minus,
434.
Yes,
yeah,
minus negative 0.34. 434.
what's the p-value?
The p-value, you have to find it, but with the graph.
It states it right there.
We don't have to find anything with the graph, Jose. The p-value is stated in the spreadsheet.
Yes, okay, let me see. Oh, yes, 0.1472. This is
0.667?
No, you got to make sure
No.
you're on the right type of test.
Q sample t-test.
Well, right, but the type of test not equal
Two.
to, greater than, or less than. So it should
Wait
be
a minute.
then.
Should be less. I thought we were finding out if they're not equal.
Right, we're not doing not equal on. Or for this one, we're doing if one. Then.
We're doing one that's less than?
Because if you look up above question 6, the null is mean 1 equal to mean 2. The alpha is mean 1 less than mean 2.
You're right.
okay. So in the
You're right.
spreadsheet, in the confidence level, I have to put 0.95.
No, 0.1.
Okay, 0.1.
Because the significance level, the alpha is at 0.1.
Ah, it's the alpha. Okay, it's the alpha. I want to write here alpha.
Man, you guys
Because
are
I will
moving.
forget.
So the p-value is 0.333.
Yes.
Yep, that's what I got.
Okay, in the
So
type
what's
of test is less than, right?
The type of test, yes, less than.
So the p-value is 90.9264.
No,
No?
no.
Nope. Are you on the two sample t-test page, Jose?
Yeah, I am.
And you're on confidence level 0.1, type of test less than,
Yes, I typed 0.1.
right?
And in the type of test is less than.
And your t is minus 0.434.
No,
Your
it's
degree?
positive.
You have them. Do you have Rexburg second or Idaho Falls second on your variables?
Okay. My
When
variables.
you copied in the data from the other spreadsheet, did you copy both columns in at the same time?
Yes, at the same time.
So in box 5, it should say 327.41.
Which one?
Column A, box 5.
Got,
Right under
okay, it
1.
is 0.
Why would it be 0?
Okay, let me see. I'm gonna copy. Oh, freak. So we're comparing. The first one is which one? Idaho? No.
Yeah, the first variable 1 is Idaho. Variable 2 is Rexburg.
All right. No. Yes, I made a mistake. A terrible mistake. Oh, I have other number.
No,
No,
not terrible. You got it
No.
before you submitted it, so that's the good thing.
I was working with. Okay, I was practicing with another other. Okay.
That's not a bad mistake. That's just a mistake.
Yes, yeah. I have my t-value is negative 0.434.
Yep.
Yes.
And my p-value is 0.333. Is
Yep.
okay? Is it okay?
Yep.
Yep.
Okay.
So based on that, the correct decision.
So that one, 0.333 is larger than 0.1.
Mm-hmm.
High, so we are going to reject, fail to
The null.
reject,
Fail to reject.
fail to
Oh,
reject.
fail to reject.
Yeah.
Okay, so
Now
number 9
suppose-
is 0.333.
Yes,
And we fail to reject.
yes.
Correct.
Okay. And we have insufficient evidence that the mean dentist bills between the two cities are the same. The last one?
No, read the question on 11.
Because now we're changing it to a not equal to as opposed to a less than.
So we need to go back into here and change it not equal to.
Right.
And it's
Oh,
still,
we have to change it.
yeah, so it's
Yeah.
666.
Okay, in the spreadsheet, right?
6, 5. Yeah.
Okay.
It's still failed to reject.
Not equal to. Okay, the p-value is 0.667.
Right. So now it's greater than the 0.1, which means that we would have sufficient evidence that
Yes.
they are.
They are different.
In this case,
No, that they're the same.
we reject it.
We would fail to reject the null, which would mean that they're equal in.
Okay,
Okay.
I'm going to get that straight
Right.
someday.
It might take me another couple months.
Yeah, but not today.
No, not even close.
So,
Yeah. All these
So in
formulas
this
and all this,
case,
it's like everything
we
going
have-
through your head and they want you to remember it all.
yeah, I know. I hear you.
Yeah, but you get a
Okay.
cheat sheet on your tests.
So in
Yeah.
this case, we have insufficient evidence that the mean dentist bills between the two cities are different.
Are the same.
I chose.
Are the
C.
same? Yes, the same. Yeah.
We have
Is letter?
We have sufficient.
sufficient.
We have sufficient.
Yeah.
But if we reject it, if we fail to reject it, we have insufficient evidence.
No. If we fail to reject, we have sufficient evidence that they're the same.
Okay, we failed. In this case, we failed to reject, right?
Yes.
Yes.
Okay, and if we fail to reject, the answer is there
Well,
is
actually, no.
insufficient evidence.
It would be insufficient that they're different. Right? And now we all. No, I always answer them.
We have insufficient C.
That there's insufficient evidence that there's a difference.
Oh, so you're going with B.
I'm going with B. Because that's how I answer it, and when I check the homework answer key, that's basically what it says. Is there's insufficient evidence to reject.
Okay, letter
Okay.
B, yes?
11B.
Yeah, yeah. Okay, freshman dinner.
B. Okay, B, right? B of boy.
Okay, let's see.
5 questions left.
So we got Utah and Colorado.
What is the appropriate alternative hypothesis?
Oh, so you know what they did here? They put Utah the first column
Uh-huh. And
and
second.
Colorado the second, but in the problem, when I read it, they say mean one is Colorado. So
No.
we're gonna have to take that and change it, aren't we?
No. The mean 1 is Utah, and the mean 2 is Colorado.
Okay, mean 1 is Utah.
But wait a minute, go back to the information they give us in the quiz. They say mean 1 is Colorado.
Oh, up there. Sorry. Yes, you're right. So
And I have
Yes.
to open that spreadsheet back up and copy that info in different.
So question 12, what's the appropriate alternative hypothesis? So if mean 1, well, they're just asking that you suspect that freshmen from Utah cooked dinner for themselves a different number of times, not less or more, it's different. So that would be not equal to, right?
Yes, letter B. Mm-hmm.
Is that what everybody's understanding?
Yeah, that makes sense.
Because it's not saying that they're doing it more or less, they're just saying different.
Oh, hold on. I have switched my information around so that the Utah 20 is the variable 2 and the variable 1, Colorado is 13.
Yeah, I hear you.
Is that going to make a difference
In the
statistics?
oh yeah.
Mm-hmm.
Okay.
We're still
So
on
the appropriate hypothesis, is there not different B?
Yeah, that's correct.
What's the test statistic?
Fred, wait, hold on. Which one's Utah? Is Utah 1 or 2?
I have 13 in variable 1.
Utah's 2. Okay.
Utah's 20, right? Starts with 20?
20, yeah.
Yes.
Sorry, I'm like, wait.
Okay. Yep, because we had to switch them around in the spreadsheet.
Yeah. Yay.
So the T-score is minus 0.845.
Are you guys doing the 2-sample t-test?
Yes.
Okay.
And we know that because we're going to do that because one reason is we don't have a standard deviation, correct? As a review, we do a T because we don't know the standard deviation?
No, because they're independent tests as opposed to a pre-test and then a post-test.
You're right. Okay.
Okay.
Negative 0.845. Is that what everybody else got?
Yep.
Yes.
Okay.
Sorry, which number?
For 13.
13 is?
What'd you guys get?
I got a 0.845.
Positive or negative?
Positive.
Okay. Nope.
Which variable on A5 do you have? 13 or 20?
So your variable 1 should be 13, 14, 7, 20, 17, 18.
Oh, I have to change.
Yeah, you have to switch. Yeah.
I have to switch. Okay, I didn't do it.
That's okay. I don't think anybody else did either. At first, it was like, wait, what? Okay, so.
So did you guys get the t-score of a negative 1.104?
No.
Mm-mm.
Okay, it's negative, yes?
So-
Negative 0.845.
Negative
Right.
0.845.
Uh-huh,
Right.
negative.
So
Did you get that, Matt?
Okay.
No, confidence level is 0.05.
Yep. With a type of test of not equal to.
Oh, 0.05. I don't have that there.
That's okay. That won't change your T-score or.
But I forget to look at that.
So
So 14 p-value is 0.411.
So when I
Yes,
copied the
positive.
2 lines over, Utah had 2 extra ones that Colorado didn't. So I didn't include those because they wouldn't be.
No, you include them still.
But it shouldn't be because it's comparing, right?
No, you still
No.
you include all of the test scores. Even
Oh,
if
okay.
there's equal numbers.
That's so.
That's
So what's the
how you
last
get
2 for the?
14 and 14.
Yeah. So what's the last 2 on the variable 2?
14
Yeah.
and 14.
14, 14.
Yeah.
You have to switch the columns. I made a mistake.
That's okay.
So it's negative 0.845.
Yeah, that's right.
Yes.
Okay, so the p-value is 4.10,
Okay.
and our alpha was
But you have to round it
0.05.
to 411. 0.4411.
Right. And it's greater than
0.05.
0.05, so we failed to reject again.
Yes.
Oh, good. They're not going to ask me what that means. Whew.
Crap.
Insufficient evidence. Oh, in number 16?
Yeah, they want the margin of error again.
How?
Now, wait a minute.
But in
And
this
we're all
case,
doing so well at that.
Yeah.
you can do it?
No, I can't.
No.
I found a formula on internet.
I found lots of formulas. None of them work.
None of them, really?
None of them work. I don't know. I don't understand. I don't know.
If we determine
I've
a
tried.
95% confidence level, don't we put a 0.95 up there in the confidence level?
Yeah.
Mm-hmm.
So that,
I have a formula
okay.
to find these. If I show you, you won't see it. I try to do it as big as I can. Okay, the margin. I hope you.
Jose, is it on your screen?
Okay, the margin is like this.
Jose, you can share your screen. Oh wait, no,
Your screen.
he's on his phone instead of on his computer.
Yes, I'm using my phone because I can see here. Okay, let me see. I am trying to make it bigger. Okay. Okay, where is it?
Hey, Dan, you're awfully
Yeah.
quiet here, bud.
My head's just spinning.
Mine
Trying to
doesn't.
Just trying to remember all this. It's just mind-boggling.
I don't know if
keep
you
down
can
on
if you can see the formula.
My problem is I write it down and I get confused.
Yeah.
Can you see the formula?
Yes.
Okay.
Go. Okay, hold on. So nobody else talk until Jose's got it talked.
No, you can see it.
Oh, hold it there, bud.
Talk again, Jose.
Okay, the margin of error equals the t-score divided by 2. And then you multiply this by the square root of, look, this is the standard deviation. I don't remember how to say, this is the variance, and here you have the number of members for the first sample and the number of members for the second sample here. This is when we have different quantities of samples.
What's the 21 and 22?
No, it's not 21. It's the standard deviation, but this is an exponent too.
Well, it's
a standard deviation for the sample, for the second sample.
Oh,
Okay.
first sample.
Wow. Okay. Okay. I well, let me see if I can.
So you're going to square the standard deviation for group 1 over the number of group 1, add the square second deviation of group 2 over the number in group 2.
But the standard deviation has a number above. It's an exponent. It's number 2.
It's not an exponent. It's just the S2 stands for the standard deviation when sigma is not known, the standard deviation. It's a standard deviation when sigma is not known.
Okay.
That's what S2 is for.
Okay.
So if we don't know the actual population standard deviation, this is the standard deviation of our sample. size.
Yes,
That's what the
but we
2 stands for.
but in the Excel file we have the standard deviation per each mean, per each sample.
Well, right, but we don't know the entire population standard deviation.
Mhm.
So the entire standard deviation or population deviation could be 4.115,
Okay.
but we don't know that. So we have to use the standard deviation. That's what the S2 1 at the bottom is variable 1, and then S2 2 is variable 2 standard deviation. Does that make sense?
I think so.
So in the
So
S21 over N1, it would be 4.517 over 10?
Over, and then 3.42 over 12. Right. Plus those numbers. And then the square root of that times 0.845 divided by 2. Right?
Well, why didn't they just tell us that to start with?
Okay. How can I share my my screen?
Close down your phone then.
Okay, I'm gonna close the phone. Yeah. Okay. How can I share my screen?
I don't know. I'm on my iPad, so it doesn't give me that option on my iPad.
Yeah, me either.
Oh wait, Jose, he can't.
Jose, go to your
screen.
Go to little.
He did.
Go left of your screen on the little green box that has an arrow in it.
Okay. Yeah. Okay. Share screen. Yes, here. Okay, can you see it?
Yep.
Yes.
Okay, here it is. Okay, we can apply this to. We have this value, look. We have this value here. We have this value here. Where is it? Here.
Yes.
Okay, and this. Okay.
Yes.
Okay, and we have to multiply these numbers twice. Okay.
No.
Yes, this is.
No.
No, square root.
No.
That 2 there is not an exponent. The S2 stands for the standard deviation of your sample.
Okay.
I think that 2 up there is just throwing things off.
Yeah.
No, the standard deviation is without a number. Look.
That's
here. Okay, that is the variance. And okay, and here.
right. It's not. That doesn't mean it's squared. That just means it's the standard deviation of your sample mean.
Okay, let's do it. But okay, we have the formula. And we need this number. Okay, we have this number. We divide that number by 2, and then we multiply by this number we have here. Okay, did you copy the formula?
Yeah.
Okay.
Nice job, buddy.
Okay.
Okay, so if I work that out.
Yeah, okay. It's okay.
I divide the 4.517 by 10 and add the 3.420 divided by 12. I get 0.7367 and find the square root of that.
Right, which is 0.85831229.7, blah, 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 blah.
And I multiply that by minus 0.4225.
Right, which gives you a negative 0.3626 or 3.3 or
Yes.
0.363.
Yes.
0.363.
But it would be negative.
Okay.
Yeah.
Would it be negative?
Yes, because we multiplied it by the negative 0.4225.
No, right, but Okay, I get. Can a margin of error be negative?
I wouldn't think so.
I don't know. I don't think it can be.
Yes, that just means that, I don't know. I don't know.
It's got to be positive. Oh.
I don't think it can be.
That's why I'm like. That's why it doesn't
It
make any
doesn't.
sense.
No, it doesn't make any sense at all.
Okay.
Oh, didn't your formula say a z-score and we're working with a t-score?
Okay.
Well, a t-score is your z-score
Uh-huh.
when sigma is not known. Because if the population standard deviation is known, then you use the z-score. But if it's unknown, you have to use the t-score.
T-score, right.
So basically, it's the same equation. It's just, t or z, but it's the same thing.
Okay, on another site, I have here margin of error equals critical value times the standard deviation. We haven't seen that before, have we?
Which one? I think I'm on the same website.
Stat Trek?
Yep. I'm reading that right now, and it's actually kind of making a little sense, which is a first. Dude, I'm not getting this.
We would still have a negative value because our critical value of minus 8.845 times the standard deviation
is a negative.
If you know the standard deviation, use the first equation, critical value times standard deviation.
Guess it can be then.
Okay, so we use this to figure out. We have to figure out the standard error of the mean. So
and that's given to us.
Oh,
that's given to us.
Yes. Then we take that and multiply it by the 95%, which is 1.96.
So we still come up with a negative number.
No, because, okay. Well, yes. Wait, hold on. Sorry. I had it. I lost it.
I think I'm there too. Just when I think I'm starting to understand.
I think I do. Okay, so we've got that. Then we take our critical value, which at the 95% confidence level is 1.96. So we multiply the negative 3.63 times 1.96. And that's our standard, or that's our margin of error.
You better state that again, buddy.
Got it. Oh my gosh, I got it. Okay. I totally understand it now. Okay, so first you have to figure your standard error. Now, the computer gives us that.
Okay.
Standard error of mean. But we have the individual one. So what you gave us is how to figure your standard error of the mean for 2 samples. Okay, so wait, hold on. Sorry, hold on. No, I think I lost it.
No, because the one Jose gave us, if you take out the Z over 2, because we're only doing one sample, it'd be Z over 1.
Just go in there. I will be there as soon as I can.
And that, if you take out that 2, it looks like our normal formula of Z times the deviation over the number.
Okay. So that makes sense. So then, yeah, then we would take the negative 3.63 and multiply that by 1.96.
And the 3.16 comes from?
Is the 95th percentile. That's your Z score at the 95th percentile. So if you use the normal probability applet and you put in 0.95 in your area, your Z score is going to pop up with a 1.95 or 96. So it'd be a margin of error of negative 0.711.
But we can't have it negative.
Well,
so you're putting in the 95 in the top of the applet to get what number out of it? The 1.96.
No, you don't put, so the app, yeah. In the normal probability applet, let me get there, sorry. So in the area, you put 0.95. Oh, dang it, come on. You put the area of 0.95 and you only select the middle, not the right or the left, only the middle with the area of 0.95, and you get a Z-score of 1.96. Because it's 2 standard deviations from, because remember the 66, the 95, and the 99.7 rule?
Mm-hmm.
1 standard deviation covers 66%, 2 standard deviations covered 95%, and 3 covers 99.7% of the population.
Why would we use that instead of the T applet?
Because when figuring the second half of this equation, after you've gotten the T value only matters for the standard error of mean when you're figuring that one. Now, because we've got 2 that we have to figure it for, it comes back in.
Wow, I'm lost, and it's okay.
Yeah, that threw me off too.
So the equation that Jose showed.
Okay.
Jose, show that again.
Oh, let me see if I can find it. Where did I put it? Let me see. Okay. Stand. Which one was it? Where was it? Okay, it's here. Okay, I will show it. Here.
Right, so we've got the Z-score, which essentially is a T-score.
Divided by 2.
Divided by 2 times the square root of each of those equations.
That's how I got the negative 0.363.
Right, but then we have to multiply to finish the equation.
95%.
At the 95%, then we have to multiply it by 1.96.
So we have to take that minus 0.363 times 0.95.
Pay attention.
0.196.
There is an example. Look, there is an example. Look at the example.
1.96. You still come up with a negative number, though.
Well, here, let's look at
Yeah.
Can you see the example? Look.
Talk again, Jose.
Okay, look at the example. I'm sharing an example. They gave us 99.5% of confidence. Look at the alpha is 1 minus that number. And we get this. And we have to divide this number by 2. And we obtain this number. Okay. For the t-score, we have to find in the applet. Okay, we have to put, in this case, this number in the applet, and we get that t-score. In this case, this score. And we are going to use this number.
You're saying we put the 0.0025 in the applet?
Yes, to find the t-score. So what we have to do is this. Okay, to find this, in this case, t-score, okay, of the alpha, we have our confidence is, what's the number of the confidence? What is it? The alpha they gave is 95, so is 1, okay, is 0.5. And that 0.5 we have to put it is
so 0.25.
Okay, here we have to put this 0.5 here. And what is our degrees of freedom? Remember? Our degrees of freedom 16.562. 16.562.
Do we have to divide that area by 2 though?
Okay, yes. So is area is 0.25. Yes. Okay, and according to this is less than, what are we using? Less than?
Not equal to.
We are using not equal to, yes?
Yes.
Not equal to. Not equal to is here. Is, okay, that is score we found is 0.690. Do you get it? Oh, no. Wait. This is 0.25. Okay, the t-score is 1.192. The t-score is positive. You see? Do you get it or no?
Mm-hmm.
Okay, now at the beginning we used the negative t that was in the Excel file, but it was wrong. We have to use this one. 1.92, and we have to multiply that by what is that? By this number we have here from the square root. So the margin of error is, okay, do you have the number of the square root? Okay.
Jose, can you copy and paste that web page into Hangouts so we can all get to that same page?
Yes, it's okay. It's okay. I'll do it. I'll do it. And where? Where is it?
I think it's up on the green. No.
Here? Is it okay? Do you get the link? Did you get the link or no?
Yeah.
Not yet.
I don't know.
Oh, I got it.
I did not.
No,
Yeah,
no,
me
no.
neither yet.
Who got it?
I thought I had it here.
No.
No.
I think you have to go to the green and do it. Is it the green box?
So down at the bottom, Jose, you've got the little green box with the quotation marks. That should pull up a separate window that has what's going on.
Okay, where is that?
Okay, so if it's 1.192,
Okay,
that number
Yep.
we multiply times 0.8583.
how did you get the 1.192?
I lied. It's the 1.192 that he pulled up on his applet.
I couldn't hear any of that and understand how he got that.
I believe he took the t-score divided by 2.
Yes.
Uh-huh.
It was 0.025. The alpha was 0.05. And he divided it by 2.
How did he get the alpha at 0.5?
Because we have a 95% confidence level.
That would be 0.05, and that has nothing to do with the area.
Yes.
But you have to divide it by 2.
It's here. Look at this. It's here.
So you don't think you put that into the applet?
I don't know what he put into the apple. That's what I'm trying to understand.
Oh, I'm sorry.
Okay, because you have to find that t-score with the 95% is the area. Yes, but it means that you have to subtract that from number 1. And then according to the formula, you have to divide that alpha by 2. And then with the new number.
Right. Okay. Subtract the alpha from what?
From the 95% they gave us in
the alpha is the subtraction from that. That's what you get left. That's how you get the alpha, is that's what's left over after your confidence level from 1. So you take 1 and minus 0.95 and you get 0.05, your alpha.
Okay, I don't know if you're reading this here. This is the example I have here in the website.
I'm not. I can't read anything you're reading, Jose. I don't have it.
No, but what happened? Oh, what happened? Can you see me? No. Oh, yes. Okay. So okay. Now here, can you see? Can you see my screen?
Yes.
Okay. This is the example I have here in the. Let's see example. With 99.5% confidence.
Mm-hmm.
I don't know why they subtract from 1, but
Because 1 is all of your number. That's everything.
yeah.
1. Remember, when we're figuring your confidence level, 1 is absolutely everybody.
Okay.
So they're figuring a 99.5% confidence level. So
But,
your alpha would be 0.005 in this instance. For us, it's 0.05.
Okay, in our case is 0.5, right? And then, as you can see here, they divide that new alpha by 2, and we have this. And with this number, you go to the applet, and then you obtain the t score for that number. So
okay, so I'm on the website. I found the page that you're on.
Okay, that's nice.
But okay, but what they're asking in that equation is determine how large n the sample size needs to be.
No. I only used that that example to find a t-score. I only used that to find the
So
t-score.
how did you find the t-score?
How did I find it? I subtract 1 minus 95% is 0.5.
That's not the t-score.
No. You have to find this new area.
Okay, but okay. So I think though that you put in 0.25 opposed to 0.025.
Here. I put this number, look. And with the degrees of freedom.
Right, that's 2, Jose. It's 0.025. Because it's not 1 minus 95 or 0.95 gives us 0.5. It's a 0.05. So 0.05
divided by 2.
Divided by 2 is 0.025.
Yes, it's okay. I have to write 0.05. Oh, it's 2.464.
Yeah, okay, so that's
the t.
Okay, so that makes sense. So then it would be 2.464. And then we don't have to divide that by 2 because we've already divided it by 2, correct?
Yeah, we don't have to.
Mm-hmm.
Okay. And then that times the square root of the standard deviation 1 divided by sample size 1, and then plus the standard deviation of 2 divided by sample size of 2. Is that then it?
Yes.
That sounds pretty simple.
Well, it's hard to come to something simple.
And that's often the way it is for me. It's one of those, okay, that was too simple. I don't know why I'm so stupid. So 0.8583122 times 2.464. So that would give us a standard deviation or a sample. Crap, what are we looking at?
Margin of error.
Or whatever the heck that thing is. I don't know. That would give us a 2.115 when we round up. I mean, is that everybody else's math then on that? That's not.
All right. Nice job, Jose. Good job helping.
Yeah.
I couldn't have done it. Okay, the last two answers. Minus 5.147 and 2.2141.
Okay, which number did you get?
2 point.
Sorry?
Are we on 16?
What number? Yes, which number did you get?
2.115.
2.15.
115.
Sure.
Okay.
Imagine that is incorrect. I have another number, okay?
That's
Okay,
right.
let's continue with the other. Let's continue with the other.
Okay.
17.
17 and
Okay,
18 we copy right off the spreadsheet, don't we?
Yeah.
So 17 is
Minus 5.147.
Minus,
and then 18 was the. Let's see what I have.
Yeah, the 2.214.
2.2114. There's a
2.21.
2.14. Okay, that's what I thought, but I would have.
We're going to go for it?
Sure.
Do it.
What we got to lose?
Nothing.
okay, for number 17,
17, we put negative 5.147.
negative 5. Negative, sorry, which number?
Negative 5.147.
You're going to die. We missed one. Guess which one?
Yeah, I'm not
there's
surprised.
16.
And
16.
18. And 18,
18 is 2.214.
2.214.
214. Uh-huh.
2.214. Okay, which
Correct.
number is incorrect?
16.
Okay, I am going to use the number I got. Okay.
What number?
Which is that? What did you get?
Okay. Okay. Let me see. 4.278.
4.7.
4.278.
On the when you submit it and you push the feedback for question 16, it says the answer in S lower than in 7 is the average between the two results. Your results should be close to the answer shown.
Okay. Wait.
Wait, sorry.
Wait a minute.
I will submit. Okay.
So once you click on feedback for question 16, it says the answer in SPSS is slightly lower than in Excel. So the answer given is the average between the two results. Your result should be close to the answer shown.
Answer shown where?
I don't know.
The answer that we gave, 2.115, is close to that, but that's not the correct one.
Okay. Okay, I'll find the answer tomorrow because, as I told you, I went to bed
Okay.
at 3 a.m. and I got
So-
up at 5.
Kevin,
Uh-huh.
do you remember that website we were both looking at?
Mm-hmm.
Yeah.
Jose was talking about.
Oh, that one? Yeah. I can,
Okay, so
the one
I
that
went
Jose-
back down further on the page, and it had a sample problem,
Uh-huh.
and it had the confidence level minus the percentage. The 1 minus 0.95 is 0.005.
0.05.
Or 0.05. Then you divide that by 2
Right?
and subtract it from 1.
No, you don't need to subtract it from 1.
Yes, they had here 1 subtract the difference divided by 2.
Okay.
First you had to find, I'm on estimation margin of error tutorial equals AP. Is that where
Okay.
you're at?
Yeah.
Bottom it says test your understanding. And then they show
Okay.
you the solution. Do you see there where it says 1 minus 0.95 equals 0.05?
Oh. Oh, so it does.
So they are subtracting that 0.05 from the confidence level
Okay. Right.
after they have divided that 0.05 in 2. So now it's 1 minus 0.025, which is 0.95.
0.975. Yeah. Okay.
Okay.
So that's the critical probability.
So I put that number in the T
Oh, okay.
part. I put the degrees of freedom in
0.57.
what it shows us, that decimal number in the T thing.
Is 0.32.
Degrees of freedom is 16.562.
Yeah. No, the T-score is 0.032.
Okay. So then if I put that in the T applet and I only highlight the first and third area,
Right.
I get 2.341.
Wait. Say what again? Where are you putting what now?
In the T curve,
Right. You have the left and the
Okay.
right. You're not doing the center.
I'm doing left and right.
And you've got an area of 0.975.
No.
Why wouldn't you have the 0.975?
Because I don't know. I should have that 0.975. Because I have 0.975 there with my 16.
Oh, okay. So the critical value, so they've got that with 899. No, that T distribution calculator. Where's that?
Oh my golly. I thought I had this and I don't. And then we're going to put 1.96. What are you guys thinking? It's awful quiet out there.
I'm trying to.
You're what?
I'm trying to understand it. I don't know.
I think I would like to just take the one missed, half missed point, whatever it is, and ask for help on this. I think we've got 2 or 3 different ideas and none of them are working.
Yeah.
Yeah, I'm with you. I can't see it. I can't figure it out either.
I'm pretty frustrated over it.
All right, hold on. I think I might have it then. So, what is what's the t value? Now I'm going to try this number. 7. Save that. Submit. What the heck? Why not? I don't know. Whatever.
You didn't get it right either?
I don't know. I haven't gotten there yet. I'm just scrolling down. Nope, sure didn't.
Well, I'm going to stop the broadcast and I'll go and post it.
Yeah.
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 That's
Okay.
all
So
tonight.
maybe we just all ask him. Our whole group would needs an explanation.
Hold on.
Yeah, I think so.
Really? So the answer is in SPSS is slightly lower than in Excel. So the answer given is the average between the 2 results.
So are they saying average the standard error of the mean?
I don't know. Is that what it's asking then?
Because we tried that last time and we got it wrong.
Did we
We
try
tried it on Monday.
Well, no, we tried the difference. We didn't try the average.
The average is 1.208. I don't know. I'll be brave and try it on my quiz, see if it works. If not, I'm just going to ask him for help because I am completely.
I'm baffled on it. I don't.
I'm
get
baffled too.
Yeah, I
Okay.
think we're all getting to that point.
Okay, let's just resubmit it, and then if it's not 1.208, then we'll ask for help. If it is, we're all going to die because we just spent a half hour and it was right in front of our face.
No, we missed it. It's not.
Did you try?
It's not it?
No, it's not it.
Okay. I didn't think it was going to be that easy, but
What was the answer on? What was the answer on 9?
9.
0.333.
And I put a negative in there.
333.
Oh, yeah.
Well, we did what we could.
Yeah.
Yeah, let's just all ask him for help on it.
Sounds good.
Sounds good to me.
All right.
All right, guys. Have a good night.
Good night. Good night, Jose. Thanks for all your help.
Okay.
Who wants to?
Who submitted?
Who wants to do the send the